Welcome back. Episode 2 dives into the relativistic era. We're exploring the expanding universe and the geniuses who mapped it. Prepare for a mental energy burst. We're profiling 10 titans of science who rewrote the very laws of our cosmic existence. Spectroscopy finally gave us the ingredients, but the engine? That remained a total, frustrating mystery to the greatest scientific minds. We knew it was hydrogen, but how does it burn forever? The source of that roaring, celestial power stayed hidden. The best guess? Gravitational contraction. But the math didn't add up, leading to a massive meeting with reality. That theory gave the sun a short life. Too short. It couldn't explain how Earth had already been around for billions of years. The puzzle remained unsolved until Hans Bethe stepped in. He looked straight into the sun's heart to find the truth. Bethe's breakthrough. Deep in the sun's core, hydrogen nuclei collide and fuse into helium, unleashing a torrent of energy. This cosmic alchemy aligns perfectly with Einstein's mass-energy equation, proving our sun is a colossal nuclear reactor. While Bethe decoded the life of stars, J. Robert Oppenheimer dared to explore the darkness of their dramatic moment. He pondered, what happens when the nuclear fire goes out? His math revealed intense end for the most massive stars.
By masterfully applying the latest knowledge from quantum mechanics and nuclear physics, Bethe painted a breathtaking picture of cosmic alchemy.
He definitively proved that deep within the sun's dense core, where temperature and pressure reach intense extremes, hydrogen nuclei constantly collide and fuse to form helium. This nuclear fusion releases enormous energy. This process functions in mathematically perfect accordance with Einstein's notable mass-energy equation. But he also showed us that every single star scattered across the night sky is actually a giant nuclear reactor. History remembers J. Robert Oppenheimer with tragedy, haunted by the blinding flash of the first atomic explosive device. Oppenheimer dared to ask a much darker question. What exactly happens when that immense nuclear reactor finally runs out of fuel? Armed with complex math, he and his team proved that when a massive star falls, gravity becomes an unstoppable tyrant. No force in the universe can withstand that colossal, inward powerful force. Gravity wins, every single time. The core collapses without end. Powerful force matter into a point of infinite density, a place where physics breaks. Its intense descent. Matter shrinks so violently it actually tears a hole in the very fabric of spacetime. Enter George Gamow. We're moving past individual stars to the biggest mystery of all. Where did everything begin? Gamow was a rare breed. A brilliantly funny genius with a vision that reached billions of years into the past. While his peers argued over expansion, Gamow was obsessed with the primordial soup of the universe's first moments. Gamow didn't just watch the stars. He used nuclear physics to propose Big Bang nucleosynthesis, the very birth of matter. He envisioned the universe, just minutes after its explosive start, as an unimaginably hot and dense cosmic furnace. Within this inferno, the first light elements, hydrogen and helium, were forged in an intense, creative burst of energy. This breakthrough finally decoded the cosmic recipe, explaining why these two elements dominate our entire universe today. But Gamow's most daring prophecy was still to come, a prediction that would eventually echo through the ages. He theorized that the Big Bang's blinding heat must have left a faint, residual radiation cooling across time. This faint echo of creation, known as the cosmic microwave background, would silently permeate every corner of space. It lingered in the darkness for decades, waiting for human technology to finally become advanced enough to listen. Fritz Zwicky, a brilliant but eccentric mind, peered into the coma cluster and saw something impossible. The galaxies were racing too fast. Visible matter alone couldn't hold them together. Something massive was hidden. He called it dark matter, an invisible gravitational glue that makes up the bulk of our reality. Though ridiculed for decades, Zwicky had uncovered a startling truth. We are surrounded by the unseen. In 1930, a 19-year-old Subramanian Chandrasekhar set sail for England, carrying only his brilliant mind and a notebook. During that long voyage, he performed calculations that would redefine the ultimate fate of every star in the sky. He discovered a mathematical limit. If a falling star is too heavy, it cannot remain a stable white dwarf. Exceeding 1.4 times our sun's mass, gravity wins. The star must collapse into something far more exotic. Leaving individual stars, we now ponder the ultimate question: the origin of all matter around us. Meet George Gamow. While many debated how the universe expanded, Gamow pondered its absolute earliest moments. He ingeniously applied quantum mechanics and nuclear physics. Gamow proposed Big Bang nucleosynthesis, where light elements were forged. In the first frantic minutes after the Big Bang, the universe's temperature was unimaginably high. It acted like a giant cosmic furnace. Gamow's greatest achievement was a bold prophecy. He predicted the Big Bang's heat wouldn't vanish, but leave a faint residual radiation. This faint echo of creation, the cosmic microwave background, steadily cooled. It permeated every corner of space. This prophecy patiently waited decades for human technology to finally listen. An extraordinary conceptual breakthrough. Fritz Zwicky peered into the Coma cluster, witnessing a chaotic dance of galaxies bound by gravity's invisible hand. The math call out an absurdity. These galaxies were racing far too fast for visible matter to hold them together. Zwicky's solution? A colossal, invisible substance he called dark matter, acting as the ultimate cosmic glue. Mocked and ignored for decades, this eccentric visionary had just unveiled the universe's greatest, darkest secret. 1930. Young Subramanian Chandrasekhar sailed for England, his brilliant mind already unraveling the final fate of stars. Amidst the ocean waves, he calculated a mathematical boundary that would forever change the landscape of astrophysics. He discovered that white dwarfs are held up by quantum pressure, but even nature has its absolute limits. Cross the Chandrasekhar limit, and gravity becomes an unstoppable crusher, birthing creatures like neutron stars and black holes. Einstein's general relativity was a masterpiece, yet its math was so daunting that even he doubted a swift solution. Remarkably, the answer arrived months later, not from a quiet library, but from the brutal trenches of World Conflict I. Karl Schwarzschild, a German physicist on the Russian front, solved the impossible while heavy equipment shells rained down around him. He mapped the exact curvature of spacetime, uncovering a mathematical secret that would eventually terrify the scientific world. Schwarzschild showed that if mass is compressed enough, spacetime bends so violently it creates an inescapable cosmic trap. Karl Schwarzschild, a dedicated German physicist, served his country on the Russian front during the muddy chaos of World Conflict I. Between heavy equipment barrages, he penned a monumental paper containing a mathematical discovery that would eventually stun the entire scientific world. With supreme skill, Schwarzschild precisely described the exact curvature of spacetime existing around a non-rotating, perfectly spherical mass. His solution pointed to an extreme consequence. Compressing a body's mass into a small enough radius causes spacetime to collapse. At this invisible boundary, known as the Schwarzschild radius, the required escape velocity finally exceeds the speed of light itself. Schwarzschild fell shortly after, never witnessing his vision become the foundation for our modern understanding of mysterious black holes. The scientific method demands proof. No matter how elegant a theory is, it remains just equations without empirical, observational backing. Einstein's general relativity, claiming mass bends space, desperately needed a definitive real-world test to verify its bold assertions. The magnificent universe we observe, brimming with stars and galaxies, is actually just the tiny tip of a giant unseen iceberg. The first to realize this intense cosmic truth was Fritz Zwicky, a brilliant astrophysicist known for his abrasive and eccentric personality. In the 1930s, Zwicky pointed his telescope toward the Coma cluster, a massive gathering of thousands of galaxies. Applying physics laws to calculate the Coma cluster's mass, based solely on emitted light, Zwicky faced a deeply absurd reality. He realized galaxies moved too fast. Visible matter alone couldn't provide enough gravity to hold the system together. Logically, The galaxies should have been violently flung out into the endless void of space long ago. The only plausible explanation Zwicky could offer was a shocking one. There had to be a colossal amount of invisible matter present. Invisible matter, neither emitting nor absorbing light, but possessing overwhelming mass, silently acted as a vital gravitational glue, holding the system. Applying physics to calculate the coma cluster's mass, based solely on emitted light, Zwicky faced an absurd reality. He found galaxies moving too fast. With only visible matter, gravity wasn't enough to hold the cluster together. Logically, these galaxies should have been flung into space long ago. Zwicky's shocking explanation. A colossal amount of invisible matter must be present. This matter, neither emitting nor absorbing light, possessed overwhelming mass. It acted as a vital gravitational glue, holding the system together. He famously called this unseen substance dark matter. Though his radical idea was ignored and ridiculed for decades, Zwicky, a visionary, opened the door to modern cosmology's profound darkness. He forced humanity to admit, the vast majority of reality is made of things we cannot see. Despite his genius, Zwicky's radical ideas were met with cold silence and harsh ridicule from the scientific elite for decades. Yet, Zwicky was the true visionary who violently tore open the gates to the profound, hidden darkness of modern cosmology. He forced us to face a startling truth. The vast majority of our reality is made of things we cannot see. Enter Subramanian Chandrasekhar. Decoding the universe requires more than giant telescopes. It demands humble scratchpads and pure, brilliant thought. His pages were filled with complex equations. Chandrasekhar's journey is a stunning testament to the absolute raw beauty of mathematics. Math can predict the ultimate fate of the stars, revealing cosmic secrets long before our eyes can ever witness them. In 1930, while sailing from India to England, a brilliant 19 adult quietly performed a series of world-changing calculations. These profound numbers would permanently rewrite the laws of astrophysics, challenging everything humanity thought it knew about the stars. In 1930, while sailing from India to England, a brilliant 19 adult quietly performed calculations that would change astrophysics forever. Scientists then believed every star would eventually exhaust its fuel and contract into a gentle, highly dense white dwarf. But Chandrasekhar, combining quantum mechanics and special relativity, discovered a deadly, inescapable mathematical limit to this peaceful end. He proved that if a star's remnant exceeds 1.4 times the mass of our Sun, quantum pressure fails against gravity's powerful force. Serving on the Russian front, Schwarzschild managed to write a monumental paper containing a discovery that would stun the scientific world. He precisely described the exact curvature of spacetime around a non-rotating spherical mass, solving Einstein's complex equations for the first time. His solution pointed to a point of no return, the Schwarzschild radius, where gravity is so strong that even light cannot escape. Back then, scientists believed stars, after burning out, would gently shrink into dense white dwarfs, slowly cooling over eons. But Chandrasekhar, merging quantum mechanics and special relativity, discovered a deadly, inescapable mathematical limit. What idea do you want to bring to life? However, his math showed if a fallen star's mass exceeds 1.4 times our Sun's, electron pressure fails against powerful force gravity. This precise mass, the Chandrasekhar limit, dictates a star's final form after dramatic moment. The universe forbids heavy white dwarfs. They must collapse into bizarre, devastating forms of matter. A revelation that paved the crucial way for the scientific acceptance of neutron stars and black holes. But his math revealed a critical limit. If a fallen star's mass exceeds 1.4 times our Sun's mass, this quantum pressure utterly fails against gravity's powerful force. This precise mass, the Chandrasekhar limit, dictates a star's final form after dramatic moment. This incredible discovery initially faced fierce opposition from conservative scientists. It established an immutable cosmic rule. A white dwarf cannot exist if it's too heavy. It must collapse into bizarre, devastating forms, paving the way for neutron stars and black holes. Karl Schwarzschild. Albert Einstein's general relativity is undeniably a masterpiece of human intellect. Schwarzschild's genius tackled Einstein's masterpiece. General relativity was a mountain of math so steep, even Einstein doubted a quick solution. He believed it would take ages for anyone to crack the code. The equations were a labyrinth of cosmic proportions. Yet, the impossible happened. A golden key turned in the lock of the universe just months after the theory's birth. This breakthrough didn't emerge from a quiet library. It was forged in the mud and intense red of WW1 trenches. Karl Schwarzschild, serving on the brutal Russian front, scribbled cosmic truths while heavy equipment shells rained down around him. Between deafening barrages, he penned a monumental paper. His discovery would soon send shockwaves through the entire scientific world. With supreme mathematical elegance, Schwarzschild did the unthinkable. He mapped the very curves of the invisible universe. He precisely described how space-time bends around a massive sphere, a non-rotating anchor in the swirling fabric of reality. If you compress a body's mass into a small enough radius, space-time bends so drastically it closes in on itself. At this invisible boundary, gravity becomes so strong that nothing, not even light, can ever hope to escape. This perimeter is the Schwarzschild radius. Here, the required escape velocity exceeds the ultimate speed of light itself. Tragically, Schwarzschild falls shortly after. He never saw his vision become the foundation for our understanding of black holes. His equations proved that physics can predict intense creature in the deep cosmos long before we can see them. Science demands proof. No matter how elegant a theory is, it remains just math without empirical, observational backing. Einstein's bold claim that mass bends space needed a real-world test, a definitive verification to change everything forever. Plunged into the eerie darkness of the total eclipse, Eddington captured the light that would change everything. History was being written in the shadows. The data was undeniable. Einstein's radical vision was reality. Overnight, the world had a new hero, and science had a new king. In a world scarred by conflict, a British astronomer proved a German's theory. It was more than science, it was a bridge across a broken world. Tragically, Schwarzschild's fall of a severe illness contracted at the military front, very shortly after completing this groundbreaking work. This meant he never witnessed his mathematical vision become the concrete foundation for understanding black holes. Through his equations, he proved theoretical physics could predict intense cosmic creature, lurking deep in the cosmos. These intense creature lurked, long before human instruments could ever hope to see them. Arthur Eddington. The scientific method demands that science never operates on pure belief alone, no matter how beautiful or elegant a new theory might be. It firmly remains just numbers and equations on paper, without the backing of empirical, observational proof. Einstein's general relativity, claiming physical mass bends space-time, desperately needed a definitive real-world test to verify its bold predictions. And the ambitious man who eagerly took on this historic mission was Arthur Eddington, an exceptionally brilliant British astronomer. Einstein's general relativity is a masterpiece of human intellect, yet its foundational equations were so complex they seemed unsolvable. Even Einstein believed it would take ages for anyone to find an exact mathematical solution to his profound cosmic riddles. Astonishingly, that elusive key was found just months later, not in a library, but amidst the mud of world conflict I. Karl Schwarzschild, a dedicated German physicist serving on the Russian front, turned the chaos of conflict into cosmic clarity. Between deafening heavy equipment barrages, he penned a monumental paper that would forever change our understanding of the universe's hidden depths. His mathematical discovery stunned the scientific world, revealing secrets of gravity that even Einstein hadn't fully anticipated. Schwarzschild precisely described how space-time curves around a spherical mass, laying the groundwork for the most mysterious objects in existence. His solution pointed to intense reality. If mass is compressed enough, space-time itself collapses into an inescapable void. These 10 incredible minds didn't just study the stars. They rewrote the very laws of our existence. From the explosive birth of the Big Bang to the silent, invisible grip of dark matter, our cosmos was transformed. We learned that space isn't a static stage, but a dynamic, expanding fabric governed by the elegance of mathematics. But as we peered deeper into the void, we found regions where light itself is devoured by gravity's ultimate power. Next time, we dive into the heart of darkness. Join us for Episode 3, Black Holes and Quantum Mysteries. We will explore the bizarre strangeness of the microscopic world and the intense secrets of the event horizon. Don't miss our next epic journey. Like, subscribe, and connect the bell to stay tuned for more cosmic revelations. The universe is calling. We'll see you next time as we continue our voyage through the great unknown. We fundamentally understood that everything in existence is drifting apart, originating from one intense, primordial energy burst. Together, through the sheer force of human intellect, we finally obtained the accurate map of an expanding universe. Yet, as brave scientists continue to look deeper into the dark, things invisible and bizarre began to quietly appear. We found intense regions of space aggressively collapsing into blind spots that devour and swallow light entirely. We discovered microscopic quantum particles and dark matter silently shaping the ultimate gravitational fate of all galaxies. Join us next time as we step into the darkness of black holes and the quantum world in Episode 3. Don't forget to like, subscribe, and connect the bell. See you next time in the cosmos. Goodbye.